Welcome back, Pre-Algebra. We're in Lesson 34. Today we're going to be talking about adding mixed numbers and rate. So first, adding mixed numbers. We know that when we have mixed numbers, such as 2 and 1/5 plus 9 and 2/5, it's really all about the denominator. If the denominators are not the same, we can't do anything with it. So that is always going to be our first step, is making sure that the denominators are the same number. So in this case, we know that we have two denominators the same number, so we can proceed to the next step, which is actually doing the addition. So the first thing we do is we add the whole numbers together. We get 11. And then we add the numerators together, which is 3. And then we just drop in the denominator. It stays the same all the way across. And that's how we would perform that calculation. But first, like I said, we have to make sure we have a common denominator. So in 34.1, they have given us some addition of mixed numbers that don't have common denominators. So they gave us problem here. And it just so happens that the denominators here all have common factors. So it's going to be a lot easier to convert these fractions into a common denominator situation. So 1/8, normally what you would want to do is you would find that denominator that's the biggest and see if you can reduce it. But when you only have one that's a prime number, we can't reduce it at all. So instead, we're going to have to bring everything up to the 8. So the factors of 8 are 2 and 4. So that means we can look over here and we see those factors, 2 and 4. So we know we're just going to multiply these two by the other factor to get to 8. Now when we multiply, we don't multiply the whole number. We're only multiplying the fraction because the fraction is the part that we're trying to change. Okay, so that the whole number doesn't have a denominator, so there's no reason to multiply it. It's already complete. The fraction is a part of a number, right? It's an incomplete set of a whole number. It's been cut into parts, and we have less than enough to make one whole set. So that's why we're manipulating it. We're not going to manipulate these because these are already complete. They're done. We don't have to change them. So here's the thing about multiplying times a whole, like the number, the other factor. We're going to multiply the whole thing, top and bottom. So 3/4. In order to get this to 8, we need to multiply by 2, right? So we need to multiply the top. Now here's the thing. Here's why we can do this. Because we know that we can multiply any number by 1 and the value stays the same, correct? 2 over 2 is another way to say 1. It's just a form of 1. When we get 2 over 2, we can reduce that. We know 2 divided by 2 is equal to 1. We can reduce that to 1. So when we multiply this fraction times 2 over 2, we're just multiplying it by 1. So the value of this fraction stays the same. I know, mind blown, but that's what we're doing. It's just a different form of the number 1. Okay? So 3/4 would become 6 over 8. So 2 and 6 over 8 plus 3 and 1 over 8 plus, now we have 7.5. So 7.5, we're going to multiply that times 4 over 4. Again, 4 over 4 is just another form of 1 because 4 over 4 equals 1, right? So that's why it is acceptable for us to multiply a fraction by a number over the same number and it retain the value that it has. So this is going to be 4 over 8. 7 and 4 over 8 would go here. Now, if we look at 4 over 8, isn't that the same thing as half? It is, because 4 out of 8 is half of 8. So that is why it retains the same value. We're splitting up the number 1 into different parts. It's still the value of 1, so it retains the value that it has to start with. But now that we have all the denominators the same number, it's a lot easier to do the math. 2 plus 3 is 5. 6 plus 1 is 7 over 8. 5 plus 7 is 12. And 7 plus 4, ooh, that 2 really looks wonky. Let me fix that. 7 plus 4 is 11 over 8. Well, 11 over 8, we know that that is more than 8. So we're going to take 8 out of here and make it another whole number. So that would really be 13, and 11 minus 8 is 3. So our remainder is going to be 3 out of 8. So this would go to this. Okay? All right. So let's look at example problem 34.2. Let's see what we can do with that. And what I want you to do with this one is I want you to take this number and I want you to solve it on your own. So I want you to do that. I want you to pause the video and I want you to solve this problem, and then we will walk through it. So go ahead, and I'm going to give you a couple seconds so you have time to pause and then write down the problem and solve it. All right, so you got 7,671 and 1/12, then you are correct. If you got 7,670 and 13 over 12, then you're not finished, okay? And the system, it will mark this wrong if you don't finish this appropriately. It needs to be this right here, okay? So, and the reason for that is that you have 13 over 12, which needs to be turned into a whole number with a remainder. So we said 13 minus 12 leaves 1. So we were able to take the 12 that made another whole number and add it to our whole number. And then we take the 1 that's left and put it back over 12 to create that remaining fraction. So this is the answer the system wants. All right, so let's talk about rate. So rate is a ratio, and a ratio is a comparison of two numbers. And it can be written a couple of different ways, but we typically concentrate on the fractional form in mathematics. If 2 apples, let's say we have 2 apples, right? Yay, yummy. And we can buy them for 16 cents. So we can buy 2 apples for 16 cents, right? That's what that line means. It means 2 apples are this. We write this ratio like this, 2 over 16. Okay? 2 for 16. So this fraction is a ratio that shows the relationship between the number of apples you can get for this amount of money. So what we want to look at then is how many apples or how many cents per apple. Oh. So if we do a reduction of the fraction, we reduce the fraction. Remember we talked about in the last lesson how we can multiply or actually we talked about at the beginning of this lesson as well, how you can multiply by the same number over the same number. You're actually just multiplying by 1. We can divide the same way. So if I divide by the same number over the same number, then I'm dividing by 1. So in this case, I'm going to divide, because I see that both of these numbers are divisible by 2, I'm going to divide by 2 over 2. So that gives me the answer that I need, that 1 apple costs 8 cents. And that's the answer I'm looking for. This problem actually said, if I can buy 2 apples for 16 cents, how many cents does 1 apple cost? So you have to take your ratio and treat it like a fraction and reduce it to get your answer. So let's try 34.3. I'm going to pause and write it up here for us because it takes a minute. All right, so here's our problem 34.3, and it says Waldo bought 5 toys for $40. What is the ratio in dollars per toy? So dollars per toy. So that would be $40 per 5 toys. But I see that this is reducible. I know that 40 is divisible by 5, right? So I'm going to take this ratio and I'm going to divide the top and the bottom by 5. And I'm going to find that I can get $8. There's $8 for 1 toy. Okay? And that's, you got to keep straight what is what. So $8 per toy. Now toys per dollar. So I'm going to write toys, 5 toys on top, and $40 on the bottom. Again, same ratio, same, it's not the same because you're doing it in different order, but we're going to do the same division because it's the same number, so they're reducible by the same factor. So 5 toys divided by 5, that's 1 toy, and that's $8. 1 toy cost $8. It's almost like average. Almost, but not quite. So that is how you would write when the question says write 2 rates. For this, you would write 8 over 1 and 1 over 8. Those are the 2 rates that the problem or that the book is going to ask you to understand. All right, that's all we have for lesson 34. I will see you in lesson 35.